In this tutorial, I'll show you how to track the local player and some simple examples using this. This is all based on a prefab created by HardLight, which is included in the Toybox prefabs. You can find the download link as well as the entire prefab database in the description. The first example is to have an indicator above somebody's head. After pressing the button, everyone will see the object floating above that player's head. The next is to have an avatar look at you. This version is entirely local, but you can have the concept from the previous example to sync it. The last example is a simplified version of my VRHat system. You take an object, you use it, and now it is stuck to your head. You can pick it up again and it'll stop following you. Now in this first section, I'll explain how to create the player tracker prefab from scratch. If you don't care about how or why things work, you should download the Toybox prefabs and skip forward to get to the examples. And with that, let's begin. So the first step is to create a canvas. Right-click, go down to UI, and click Canvas. This will create the canvas object and the event system, but we can ignore that. So all the player tracker system is a canvas that is just located at the player's camera. So let's rename this object here and call it player handle. I'm using this name just because it's the same name that's in the Toybox prefabs. Next, we do not need the graphics raycaster or the canvas scaler. And now on the canvas component, we need to change this from screen space overlay to screen space camera. Some of the options are hidden here, so drag any camera into this render camera slot. It doesn't matter because this will just be overwritten later. And so you'll see this plane distance appeared. Its default is at 100, but we actually want it to be at 0. And as you notice, the canvas just moved over to the camera's location. So it's moved to a camera, but this is not the player's camera, so we'll need to add something to get it to the player's camera. So add component, VRC, UI shape. So normally this is used to add onto canvases to allow you to interact with them, say like the UI buttons, but in our sake, it's just going to be used to change this render camera to the player's camera. But this UI shape does another weird thing, as it will add a box collider if it doesn't have one. And we kind of don't want that, so go ahead and add a box collider and then just disable it. And with this, you have the most basic player tracker. When you click play, you can move the camera and notice that the tracker is still there. But this has some problems and it's not perfect. If you use this tracker, you cannot child anything under it, as everything will have a scale of 0. Another issue is that if you use any form of like following scripts, those scripts will be 1 frame delayed. It may not be obvious in the editor here, but it will definitely be obvious in game. So let's fix those problems. First thing I'm going to do is take the player handle and I'm going to duplicate it. And I'm going to rename this one basic just so we have it for later. And turn it off, but that doesn't matter. Back on the player handle. First thing we're going to do is we're actually going to disable the canvas script. We don't need it anymore. It'll just mess with some of the settings that we'll want to change. As you can see, the scale is still set to 0 and we do not have access to change it. So we'll need to add something in order to force it back to 1. So click on add component and type in animation. So you'll see there's 2 options. Make sure to click the first, which is animation and not animator. Animation is the legacy component, which allows us to do different things, but specifically we need a function that is on it. I'll get to that function later on. Now that we have the component, we need to add a clip for it to use. Go into the animation tab over here, click the create button, and then I'm going to create a new folder for organization and call this player tracking. Inside that, I'm going to create a new clip and call this lock scale. So in this, click on the add properties, go to rect transform, find the scale property and ++. I'm going to change all of these values to 1 because we wanted to lock it to its default scale. And then I'm also going to delete these last keyframes. So it's just 1 keyframe. And if you notice, it didn't actually fill it in here. So I'm going to go into player tracking folder and drag that in. And it's there. The last step, which is kind of weird, is we actually want to turn it off. In the next step, we will be manually calling this animation to set the scale. So in order to manually call this, we'll need to create our own update loop. So inside player handle, create a new empty object. I'm going to call this update. And then on here, I want to add a UI button. If you've seen my tutorial 4 on object teleportation, you'll know that we can use animations to call into UI buttons. So we'll need to create this animation now. So on this button, add an animator component, not the animation like last time, but the animator. So next, inside the assets, we will need to create new animation controller. And I'm going to call this event selector always, using this naming scheme just because that's what was on the Toybox. So drag this in here. And then in the animator tab, we have nothing, so we'll need to make one. I'm going to create a new, and I'm going to call this event selector. All this animation is going to do is we're going to call the button's on-click events. So this thing. And to do that, you can go over here to add event, which will add a new animation event. Animation events allow you to call functions on the objects that are on this animator. So this list is populated for all the functions that are on this. And so we were going to select press. You can also use this to call into custom triggers that are on the same game object. It's really useful, but we're not going to use it here. So in the clip that we just made, we're actually going to uncheck loop time. And then go back to our animator, and you'll see the clip is here. So what we'll need to do is from any state, make a transition, and go to this new one. And also we're going to need a Boolean parameter. I'm going to call this true and just have it checked. And for this transition here, I'm going to add a condition that true is true. So every frame, it's going to see that true is true and go down this transition from this state back to itself. And to enforce that it goes every single frame, set the duration to 0. And so now, every single frame, it'll go through this animation, which means every single frame, it'll click this button, performing all of these actions. So now let's add the actions. We are actually going to need 3 different things here, and for all 3 of them, drag the player handle in. So for this first 2 actions, you'll need to go in here to find canvas and find, let's see where it's called, scale factor. So setting both of these scale factors. The first one, we're going to leave as 0, and the second one, we're going to put at 1. I'll be honest, I have no idea why this works, but HardLight found that having both of these set will move the player handle to the camera even though our canvas is disabled. So for the last action here, go in, find animation, and find sample. This method is only available on the legacy animation component, which is why it's important. But basically what will happen is it'll take the current frame in the animation and apply it to the game object. And with this, our tracker should be complete and should be at a scale of 1 at all times. So let's show how that works. I'm going to create a cube here, and as you can see, it doesn't show up because it's set to 0, it's right here, but when I press play, the cube will appear over here. Yep, there's a cube on the camera. And now I'm going to delete that. I just noticed that after pressing play, it's allowing me to edit the rect transform here, so I'm just going to manually set the scale to 1. That way you can actually see what objects you're putting inside. Now that our tracker is done, let's start making some examples for it. An important thing to note about this is that this object is local, meaning it will only be at your camera's location on your client. Everyone else will have it on their camera's location. If you need to do anything that is synced with it, you have to do some weird special things to ensure that it is in the proper location. This first example will be one of those special things. It will make a synced sphere follow a player after hitting a button. So first thing, create an empty game object. I'm going to use this for organization, and I'm going to call it follow sphere and reset its position. Next, create a sphere. So as a child, create sphere, and I'm going to resize this to 0.2 and remove the collider. I am also going to move it up to 1.5 and then add a VRC object sync. Let's see. Make sure to uncheck allow collision transfer. So the sphere here is synced, but we need to now move it to the player's location. So in order to do that, we will need to add the follow target script here. So you may not have this follow target script because it is included in standard assets. You can import standard assets by going up here to assets, import package, and selecting these. Follow target is in utility. If you do not have these options, you can also go to the asset store and search for standard assets to download the entire package. In this follow target script here, you'll notice that there's a target, and that we want to be the player handle. So I'll drag that in. Next, by default, it has an offset. So this offset is in world space, meaning that this sphere will be located at this position plus this offset. And 7 is really high, so I'm going to change that to just 0.5. So it'll just always be slightly above the player's head. And next, we actually want to disable it. When dealing with synced objects, if we are going to force the position, we only want the person who owns the object to have this enabled. And we'll do that in the button. So create a new cube as our button. I'm going to then rename it. As usual, shrink it down and then raise it up so it's at a nice height to press. Next, add a VRC trigger. Make sure to click the advanced checkbox. When you start building complicated things, you'll need to be careful of what the broadcast type as well as the order of execution is. So for this one, I'm going to add an onInteract, and I'm going to set this to local. The first thing that we need to have happen here is that we need to tell everybody to stop using the sphere, and then the person who interacted here begins using the sphere. The way we're going to describe using is whether or not this follow target script is enabled. So first thing we need to do is tell everybody to turn off the follow target script. Since this is local, we need to then broadcast this in a custom trigger. So add a new custom trigger, set it to always unbuffered, call this disable, and then in the actions here, click basic events, set component active, drop this down, drag the sphere in here, select follow target, and leave it at false. So when this gets called, it'll turn the sphere off for everybody, or turn the following of the sphere off for everybody. But we need to call it. So on the interact, add an activate custom trigger, click this open, drag the button in, and let it disable. So when somebody interacts with this, it will tell everyone to stop using the sphere. But now the person who clicked the button needs to start using it. So first thing, choose from events from scene, go to sphere, and take ownership. So when you have ownership of an object, you are the one calculating the physics of it and sending that to everybody else. Taking ownership is the way for you to say, I want this to follow me. So back here, once you've taken ownership, set component active, drag the sphere in, again go to follow target and set this to true. At this point, you now own the object, so you are telling everyone where it should be, and now the sphere should be floating above your head because of the follow target script. And with that, we now have a synced sphere that is following you, the local player. If you've seen my tutorial on custom triggers, you will recognize that this behavior here is how to perform different logic per player. So the first step is to tell everybody else to do something, and then the person who clicked it does the opposite. When dealing with synced objects, you are required to use this technique, because only one person should be controlling the object. With that, we can move on to our next example, which will be having an avatar look at you, the local player. This version will not be synced, but combining the techniques from the last example, you can sync it. The first step is to find an avatar to drag that into the scene. I'm going to use Fred, who is the tutorial avatar. Wildclaw is the one who named him Fred, and the name's just kind of like stuck since. So if you type in tutorial and drag him into the scene, we get Big Blue Guy. I'm going to just move him out of the way for now, slightly rotate it just because. You can either pose him manually or go to somewhere like Mixamo.com and find an animation and give it to him. I'm just going to be lazy and pose him manually for now. Inside the pose, I'm going to crawl down his armature and I'm going to find right arm. I'm just going to lower that, find the left arm and also lower that. And then next is the actual magic happens. So we have this head bone here. If you have an animation, you will want to rename this. I'm just going to add an underscore so it's something different. This will break the path in the animation and allow you to do whatever you want on it. And so now that it is broken, you can go to add component and you can type in look at target. So this script is part of standard assets again. If you don't have that, you can go over to import package. Cameras is where look at target is. There are a few options on this script specifically. The first one being target and auto target player. Never have this checked. So it'll try to find a game object called player, and while the players in game are tagged with player, you are not guaranteed to find you, the local player. So there's a chance you could find somebody else, and that's pretty much useless. So uncheck that. And inside target, we're going to drag player handle because that's what we want to be looking at. The next step here is update type. Default is fixed update, which is the same loop that is run for physics, and I'd rather choose late update, which happens after everything updates, including our update loop that we created manually. And next is the rotation ranges. This is basically the limitation around each axis he is allowed to turn. And if I go over to this, you'll see the blue arrow. This is what's going to be rotated towards our target. So if you leave it at 0, it can't rotate at all. And so for this, I'm going to put a small value for X, meaning he'll only look up and down a small amount. But for Y, I'm going to set it to 90. And the last option here is speed, which I've said before is the most confusing thing ever. If you set it to 0, it becomes instant. But if you have it a higher number, it is slower to turn. For this example, I'm just going to set it to 0.1. And that is all you need to have him turn his head towards the player. If I press the play button, you'll see his head just rotates around. I mentioned at the beginning that this is not synced, and as an exercise, I challenge all of you to find a way to sync it. I'm not going to go over it, but you'll just have to combine with the last example. There's two different ways that I can suggest. One would be adding the object sync here and doing the same thing you did before, turning off the look at script. The other version would be to just have him look at, say, the follow sphere instead of the player tracker. For this last example, I'll explain a simplified version of my VRHat system. I suggest you check out the map to see what it's like. After I released that map, a Japanese user by the name of Null released his own version of the system in his prefab pack. It has other interesting things in it, so I'll put a link in the description. Note that our systems are different, but attempt to do the same thing. My system works such that when you click the Use button on a pickup, it will stick to your head. When you pick up the object again, it stops following you. This is all done by reparenting the pickup object. If you have seen my tutorial 4 on teleportation, I mentioned that it didn't work on synced objects. While this is true, it turns out that reparenting the parent of a synced object works fine. Object sync is weird. So the first thing we'll need to do is set up a weird parenting structure for all this. Right click, create new. I'm going to call this VRHats. This is just the overall organization object. Underneath that, create another one, and I'm going to call this VRHat pair, which is going to be the parent of our pickup object. Last, create another empty and rename this VRHat pickup. Okay, so on this VRHat pickup, go here and add a VRC pickup. In the rigid body that is added, make sure to check is kinematic. In the pickup script, make sure to go to auto hold and set this to true. Go here, add a sphere collider. I'm going to make this only 0.1, and also add a VRC object sync. And as with last time, disable or uncheck allow collision transfer. So now this is the pickup itself, but let's add a visual. I'm going to just add a sphere, remove the sphere collider, and set this to 0.2. You could, in theory, have it on the same object here, but I just like having it as a separate object as a child. Back on the pickup object, I'm going to add a VRC trigger. Inside here, make sure to click the advanced checkbox. And we're going to add both an on pickup and then also an on pickup use down. So for this pickup, make sure to set it to always unbuffered. For the on pickup use down, set it to local. Now, we don't have everything set up to do the actions yet, so I'm going to leave these blank and set those up first. Underneath the pickup, which doesn't actually matter, create a new game object, and I'm going to call this reparent. This object here will do all the work to stick the sphere onto your avatar. So first thing I'm going to do is actually turn it off, add a button, and then we'll also need to add an animator to click this button. So we already have our event selector always, but we don't want it to always happen, we just want it to happen once. I'm going to duplicate that and then rename this to once, again using HardLight's naming scheme. Find this arrow here in the event selector once and delete it. So now what will happen is it will only click it when the object is enabled or when the animation starts. It will not do it multiple times. And to guarantee that, you can check if there's a loop, so it doesn't. So back on reparent, drag the event selector once on here. And now when this object is turned on, the button will be clicked and nothing else will happen. So let's add some events. For this, we'll actually only need 2. Add both of those. For the first, set itself in. And in order to make this reusable, I'm going to set itself off. So as soon as you turn it on, it does the actions, turning itself off, and then the main thing here. Which for this, we need to go to VRHat pickup and set that in here. Go into functions, set transform, and find set parent. Because this is reparenting, what we're going to do is we're going to take this VRHat parent and we are going to parent it under the player handle. So basically, when you let it go, the object will just follow based off your head movement. And now the other portion of this is to undo it. So duplicate the reparent object, set this to release, and inside this, instead of setting it to the player handle, I'm going to set it back to the VRHat's object. And that's it for these buttons. All we need to do now is link it with our triggers. So on pickup, you're going to tell everybody to release the object, making sure that it is on no one. So on pickup, release, and set it to true. Inside on pickup use down, we're going to locally only activate it for ourselves. So then in here, we set it to reparent. Set that to true. And with that, we have the most basic system for VRHat, which you can also just take this and duplicate it. But we don't need to do that for here. If you're noticing a pattern here, this is doing the exact same thing as the first system. On pickup, you're basically telling everyone to stop using the object, and then locally when you use it, you're then only using it yourself. It may look different, but it is pretty much the same thing. One extra thing that is not obvious is that since you are holding the object, you have ownership of the object, so you do not need to explicitly take ownership of it. So after building this system, I forget that most people don't know about it. I'll see a kinematic pickup in another world and I'll try to like click it onto my head, but then get sad when it just stays there and not moving with me. But hey, now you guys know how to do it. Make your own VRHats. If you have any questions about this tutorial or anything trigger related, I recommend going to Discord instead of the comments. Discord is much faster for answering questions. Official Discord has multiple world-related channels and people who can help you answer these questions. If you want to keep up with what I'm working on for VRChat, you can look at my Twitter or join my Discord. If you want to support me in creating new tutorials or VRChat worlds, visit my Patreon. Until next time, thank you for watching.